Hi, everybody. I got a question in my email on section 8.4. This would be homework problem number 1, and I'm really glad I got this question because I did not cover this in the video. I was kind of hoping it wouldn't come up. All right. So this problem says, a simple random sample of 43 men from a normally distributed population results in a standard deviation of 10.3 beats per minute. The normal range of pulse rates of adults is typically given as 60 to 100 beats per minute. If the range rule of thumb is applied to that normal range, the result is a standard deviation of 10 beats per minute. Use the sample results with a 0.05 significance level to test the claim that the pulse rates of men have a standard deviation equal to 10 beats per minute. So the first thing they're asking for is the null and alternative hypotheses. So let's look at our claim. The claim is that pulse rates have a standard deviation equal to 10 beats per minute. So, symbolically, it would be sigma equals 10, and the opposite of that is sigma does not equal 10. Okay. Remember that does not equal would be the alternative hypothesis because it doesn't contain equality. And so that has to be choice B here. The null hypothesis is sigma equals 10. The alternative is sigma does not equal 10. Okay, so far no problem. Okay, now they want me to calculate the test statistics. So I am going to go over to my tablet for that. Okay, here we go. So the formula for the test statistic for this type of test is chi-square equals n minus 1 times s squared over sigma squared. Okay, so n is the size of the sample that was given as 43. S is the sample standard deviation that was given to be 10.3. And then sigma would be the standard deviation from the null hypothesis, so that would be 10. All right, so when we crunch those numbers, messed up. Let's see here. Oh, I know what I did. 42 times 10.3 squared divided by 10 squared. Comes out to 44.5578. So I'm going to be super careful. I'm not going to round that off at all. Well, except what are the instructions? So let's go back to the problem. Round to 3 decimal places. So to 3 decimal places, that would be 44.558. All right, no problem with that. Here's where the problem comes up. So this is a two-tailed test. I did not explain in the lecture video how to calculate p-values for two-tail chi-square tests. I said that I thought it was a little more complicated than what we needed and that we could just use the critical value approach. Well, I didn't realize that there, bam, right away, homework problem number 1 was going to ask you for a p-value. I was hoping if it asked you for a p-value, it would ask you for a range. Okay, well, live and learn. All right. So unfortunately, my favorite website, StatTrek, is not good enough for this problem because when I first got the email about this problem, I tried it on StatTrek, and for some reason, StatTrek is rounding the p-values to 2 decimal places, and your homework wants it rounded to 4 decimal places. So when I tried to enter my answer from StatTrek, my math lab didn't think it was good enough. So I looked around and I found a different website that does round them to 4 decimal places. So if you go to Google and you type in p-value calculator chi-square, the first site that comes up is this thing called SociSciStatistics.com. So this is statistics for social sciences. Social sciences do use chi-square tests a lot. So I'm going to click on that. Now I need to explain to you though what this result is going to mean. So I'm going to enter our chi-square score, and you know what? I'm going to put in the unrounded value 44.5578. Oh, never mind, it won't let me do that. And there would be 42 degrees of freedom. You can see I was playing with this already. Now it's asking for the significance level. That's not super important because I think we know how to interpret it. And also you want to be careful about this because I haven't told this website, is this one tail, two tails? So we're just going to get the p-value out of it. However, the p-value that comes up is not going to be the p-value for our test. I need to show you how to tweak it. So I calculate that and it gives me a p-value of 0.364638. Okay, so now I'm going to draw you a picture. Switching back to my tablet. 364638. Okay, so remember that a chi-square curve looks something like this. It's not symmetrical. That's what makes two-tailed tests kind of a pain. So what this p-value is telling me is that for a chi-square value of 44.578, the area to the right of that value is equal to I already forgot, hold on. I think it was 364,678. I'll double check it before I enter, okay? All right, now here's where you have to be super, super careful because the problem that somebody emailed me yesterday, it had a smaller chi-square value and the p-value came out to be bigger than 0.5, okay? So what I need to tell you is this is going to be, okay, let's put it this way. Because that value is 0.364678, that means the area to the left would be 0.635322. Okay. Now, if the website had given me that value, I would have needed to subtract that from 1 to get the value that is smaller than 0.5, okay? Because this is going to be the area in my right tail, which means I also want to include an area in the left tail equal to 0.364678. Okay. So that means that the p-value that the problem is asking for is going to be 2 times 0.364678, which comes out to 2 times 0.364678 comes out to 0.729356. Okay. So that's the value that my math lab wants. But again, I want to tell you, be very, very careful because it could happen in your version of this problem that the p-value from the website is greater than 0.5. If that happens, you need to subtract it from 1, which would give you this value, and then that's the value that you want to double. Because if you doubled this value, it would give you 1.27 or something. And remember that a p-value is a probability, so it can't be greater than 1. Okay? So 0.729356, switching back over to my math lab. 638, darn it. Okay, I got one of my digits wrong. I don't think it'll matter. It's asking me to round it to 2 decimal places. 638. Okay. Actually, it does matter. It's going to make my final answer 0.7293 instead of 0.7294. Okay, so 0.7293. All right, and that's how you do that, okay? So it was really just the p-value part of it that I was worried about because, again, the lecture video did not explain how to do this for a two-tailed test. All right, so I will stop it right there because I think that you're probably going to be okay stating the conclusion.